Alright everyone, welcome to homework 3.12. Today we looked a little bit more at finding the original value. I'm going to start with these problem reviews. This is just to go over some, again, test-like questions. So the cost to make n necklaces can be represented as C of n. Which statement is true about function C? If C of 90 equals 180, then making 90 necklaces costs $180. If C of 90 equals 180, then making 20 pairs of jeans costs $2. Okay, there's literally nothing about jeans here, so that doesn't even make sense. If C of 90 equals 180, then making 180 pairs of jeans costs $20. Again, we don't have anything about cost, and these are all about jeans. So this is our best answer. It tells us that the input is the necklaces, the number of necklaces, and the output is the cost of those necklaces. It says which inequality matches the graph below. So notice here that we have our shading underneath and a dotted line. So that can help us to eliminate A and B because we have less than or equals to there. And so then the next thing we would want to look at is the slope of the line. This slope of the line is a positive slope, and so that helps me to eliminate D, which has a negative slope, and so my best answer must be C. For this one, we have a solid line this time. Now, all of my options are both greater than or equal to or less than or equal to, so that doesn't help me eliminate as much. We can eliminate the type of slope we have here. So this is a negative slope. That helps me to eliminate both A and C. And so now I'm left with, is it greater than or equal to or less than or equal to? Well, let's test a point. If we were to test this point 0, 0, and plug in 0 is greater than or equal to 0 plus 2, well, 0 is not greater than or equal to 2, so it can't be B. It would have to be D, because this point is in the shaded area, and 0 is less than or equal to 0 plus 2, or 2. So D is our best answer. All right, let's get into today's practice problems. So here are equations defining three exponential functions, f, g, and h. Which of these functions grows the least quickly? Which one grows the most quickly? How do you know? So here A is all the same, meaning our starting value is all the same. And so in this case, the one that grows the least quickly is f of x, because the factor is only 3. In comparison with h of x is the fastest growing, because the factor is 4, which means it is growing much faster. Part B says the three given graphs represent f, g, and h. Which graph corresponds to each function? So we need to figure out which one is f, g, and h, looking at these three right here. So we know that h of x is the fastest growing one, so that would be A. So A is h of x. B then, which is the middle one, would be g of x, because that is growing at a rate of 3.5, or a factor of 3.5 rather. And then the slowest growing one is C. Oops, we can see that graph is growing a little bit slower there, so C would be f of x. Why do all three graphs share the same intersection point with the vertical axis? Meaning, why do they all have this same y-axis intersection, or y-intercept? And that is because all have a starting value. If we go back into our equation of 100. Oops. All right, so that starting value is the same for all three graphs. Now it says here are three graphs of three exponential equations. Match each equation with a graph. So this time, we're looking at the starting value being different. So the one with the lowest starting value would be m, and the next lowest, right, at 50 would be here, so that's L, and then the highest starting value is K. Now here, the factor is the same for all of them. It's being multiplied by the same number, but we have, in this case, different starting points. Number 3 says the function of f is given by this equation, and the function g is given by this equation. The graph of f is labeled a, and the graph of g is labeled c. So this is our first one, 160 times 4/5 to the power of x. And notice that means it's retaining the most of its value since it's decay. And this is 160 times 1/5 to the power of x. It says if b is the graph of h, or the middle, and it's defined by this, what can you say about a and b? So a is 160 because it's starting at the same starting point. And then b right here would be our factor. Now, in this case, it is decreasing between the 1/5 and 4/5, right? So here it's retaining a lot of its value, and here it's losing a lot of its value. So b would be between, let's go, between 1/5 and 4/5. Somewhere between those, we know it would be losing its value, right? Not quite as fast as C, but also not as slowly as A. All right, here is the graph of 100 times 2 to the power of x on the same coordinate plane. Sketch a graph of 50 times 2 to the power of x. So 50 would be starting here, but it would more or less have the same curve, right? It's going to follow the same shape as this one because it's growing at the same rate. Sketch a graph of, so we'll label that A. Then it says sketch a graph of 200, and so here we're starting up higher, but again we're increasing at about the same rate, right? So our curve should more or less be the same. All right, number 5 says choose the inequality whose solution region is represented by this graph. So again, this is a review, and so let's go ahead and take a look at what this could possibly be. So we can start by looking at the line, which is solid. So that means it has to be B or D. We can eliminate A or C. And then what we can do is we can test a point. So we know that 0, 0 is the easiest point to test, and it is not part of the solution set because it's not shaded in. So if I plug in 0, 0 here, I would get 0 minus 0 is greater than or equal to 12. Well, that is not true, and we also want it to not be true here because this is not the shaded area. So B is actually going to be our best solution. If we were to plug in 0 minus 0 here, we would say that is less than 12, but then this side would have to be shaded, and it is not, okay? If you want to verify, you can also select a point in the shaded area, right? So for example, 2, negative 2. So if I were to do 6 minus 4 times negative 2, right? That is greater than or equal to 12 because this would be 6. Negative 4 times negative 2 is positive 8, so 6 plus 8 is 14, and that is greater than or equal to 12, so we know that B does in fact work. All right, let's take a look at this next one, which I have already done some setup for. So here we're looking at this equation, and it gives this factor of 1.05, which means it's increasing by 5%. And we're looking at 10 years. So here we're looking at finding the average rate of change. And so if we're looking at the average rate of change, we're going to need to use our formula, and we're going to be using essentially slope, right? So our initial value is 500. Oops. Let's go ahead and fix this because I want to get this graphing calculator up so you can see it. And so we're going to go ahead and plug in if we are looking at 10 years. So we have 500 times 1.05 to the power of 10, right? That's how much it will be after 10 years. And so that is 814 we'll say 45. So go ahead and minimize this. So 814.45 minus 500 divided by 10. And so let's go back to that. All right, so minus 500 and then divided by 10 is 31.44. So in this case, our average rate of change is 31.44 dollars per and year, because our measurement of time is years. All right, so the next question says, is the average rate of change a good measure of how the bank account varies? Explain your reasoning. So here, if we look at this graph, this is showing us what it looks like over 10 years. And actually, over these 10 years, it seems to be rising at a pretty consistent rate. And the reason this appears to be that way is because we're looking at a rate of increasing only by 5%. So if we look at the average, or we look at the change in the first year, it will be less than 31.44. And if we look at the end, it'll be more than 31.44, but not too far off. So let me show you what I mean. So if we were to look at 500 times 1.05 to the power of 9, that's the 9th year, right? And then 500 times 1.05 to the power of 10, that's the 10th year. Right, this is the difference here is 814.44, we'll say minus 775.66. That gives us a difference of 38.78. So from years 9 to 10, it grows, let's see, what did I say? 38.78. So 38.78, right? So that's more than 31.44. And if we were to look at how fast it grows in the beginning, right, the starting amount is 500. So this after 1 year would be 1.05 to the power of 1. It would be 525. So 525 minus 500 gives us 25. And so from 0 to 1 year, it grows 25, which is less than 31.44, but not super far off. So we would say this is an okay measure for these 10 years because it is only 5% that's changing. But we would say it is too large of a change to represent the beginning growth and too small for the end growth, right? So in comparison here and in comparison here, it's a little bit off, right? It's not a ton off, but it's a little bit off. And again, when I looked at this earlier, and another day we talked about how if it's over a longer period of time, it generally isn't an exact or very, very close measurements, the average rate of change to what's actually happening and how it's actually changing. However, because again, we're changing at such a small amount, 5%, we're not seeing such drastic changes. If we were to multiply this as a factor of 2 by doubling instead of multiplying by 1.05, we would see that that average rate of change would definitely not be representative over 10 years. And because we're only increasing by a little bit, this isn't the worst measure, that 31.44 in this case. All right, your code word for today is wave. Wave is your code word for today. Again, remember to write that at the top. If you have any questions, please feel free to reach out. Happy homeworking. Have a wonderful weekend, and I'll see you on Monday.